Hi, in this video, I'll be demonstrating how you can implement leader election in Kubernetes. So let's get right into it. So what is leader election? Leader election is a very common pattern using distributed systems to establish order and coordination amongst instances of a running service. Its purpose is to ensure that a single node or instance takes on the responsibility of performing specific tasks, while other instances remain in a redundant state and are ready to take over in case the assigned node fails or encounters any issue. For example, let's say we have a critical service which has a responsibility. Uh, Sorry about that. Let's say we have a very critical service. Oh, what's going on? We have a very critical service which has the responsibility of performing batch processing tasks and and needs to be run periodically each day to ensure high availability and fault tolerance. For this system, we decide to introduce multiple instances of it, right? Um, we decide to introduce multiple instances of this service to ensure high availability and fault tolerance, right? However, um, these services, there is no coordination amongst them, right? Once you deploy them, the three services just start running. But I mean, that's not what you want. You want to ensure that there's coordination amongst the three of them, right? So that the three won't end up processing the same data, right? And which could eventually lead to data inconsistency in your system. What you can do here is to deploy a leader election mechanism, right, to ensure that there are coordination amongst these three services or these instances. So the job of the leader election mechanism is to ensure that at each time possible there's always a single instance which is known as the leader, saddled with the responsibility of running the workload which you must have prepared the service for, right? While the remaining two just remain in a redundant state and are ready to take over whenever, let's say, this node fails or this instance fails, right? So that's basically how a high level the AI level explanation of how it works in a distributed systems in this distributed system. Example of such mechanism that you can actually, or be the election mechanism that you can deploy is raft and paxos, right? But we won't be going too deep into how leader election works in a distributed system, right? So that will be focusing more on Kubernetes. So how does it then work in Kubernetes, right? It works actually almost, if not the same way, only that Kubernetes adds in its own way of of its own approach of handling leader election. In Kubernetes, Kubernetes uses some objects like leases, config maps, and endpoints, right? Depending on the approach you want to take, right? But it uses any of these three to establish leader election. But in this video, we'll actually be focusing more on leases, right? A lease general, the way it works is your application whenever it starts, right? Or in Kubernetes general, there's a lease, right? The lease contains timestamp and an identity. Yeah. So the identity signifies who is currently the leader, right? And you have a couple of pods whereby whenever they start, they try to acquire the lease. And by acquiring this list, it means you are the leader, right? And basically you just updating the list object, right, makes you the leader. Yeah. So and once you are the leader, then you start performing the tasks, and all other pods remain in a redundant state. And whenever anything happens to the pod, right, so the leader election process immediately kicks in, and a new leader election a new leader is selected, to run the workload. This might sound a little bit abstract, but I've created a I've created a sample application for us that we can further use to demonstrate this. This is actually an application. As you can see, it's written in Go. Its main purpose is to to just basically run a service. Um, so from the project structure, we can see this is the main directory. It just contains, we're trying to get some values from the environment. We have a context. We have a Redis client, whereby we, create, where we, set up our Redis instance, and also, as some methods that we can use to manage our Redis system. So connect to Redis, basically. And we also have a processing data, which is just used to model our service, you know performing some action. The code here is just very simple, very, very minimalistic, so nothing too serious. But the idea is to just give you that understanding of how it works in general. So that being said, let's do a quick run through of what we have right from the top. So we have a K8 folder, so which contains, and the deployment contains all of our deployment configuration or manifest file. The first is for the Redis instance, used to start Redis instance. The second one is actually for our application, right, which is a bit longer, right. It contains an init container, which is just to ensure that, we are our Redis instance is Redis instance is ready to accept requests, right? So basically just checking if the service is available for request using the Redis service fully qualified domain name. When the service is up, right? So actual container can start being created, would be created. We also have a service for a service directory, or a service file rather, that contains us manifest for the Redis service, and also for the application. Um, that being said, so before you actually run this service, you need to have a couple of application or some technology installed on your system. The first is Scaffold, right? So we are actually using Scaffold to deploy our application locally into our Kubernetes cluster, right? So to download that, just head over to scaffold.dev and download the CLI. The other one we are using is KIND. KIND is otherwise known as Kubernetes in Docker. Allows you to create a Docker instance. Allows you to create a Kubernetes instance, right inside of a Docker container. And you also need to install kubectl, right? You also need to install kubectl if you haven't. So let's jump right back into the code. So we have a cluster configuration. This is a kind specific installation, right? Configuration, so to say, or so to speak. What this does is, it creates a control plane, a worker node, and two worker nodes, right? That's what it does, using the kind configuration. I mean, to read more on this. I won't be, going too deep into this because I don't want to bore you with too much information, especially if you are not too familiar with kind. But just to give you an idea of what's going on in the files, right? You don't need to pay too much attention to this. And we have, a very basic Docker file, right, which has been uh, just the basic Docker file to build our application. Uh, right, so we have a go mod file and go sum file. We also have a main go file, right? Our entry into the application. Uh, yeah, so we have our Redis instance, and we're just doing some funny, just trying to ping Redis until Redis is available, right? And once Redis is available, application starts. We have some routes here, get and also points, which just gets points from Redis. Um, and yeah, after that we created a server, and ran a server in a Go routine, and also we are running our process. I mean, we are processing the data, or we run the process function to start processing data from the uh, in a Go routine, right? So it takes in a context and an identifier. The identifier is actually coming from here, which is the name of the. If you check the deployment, is an environment variable we've passed in, and using the name of the current port, right? Um, what else? Okay, so we basically have a channel here, which we use to kind of block the whole application. I mean application, right? Until when we get a sig int or sig term event, and then once we get that, the means that we probably want to kill the application, and we try to gracefully shut down our application. We also have a makefile. The makefile contains some commands. The first one is clean kind. So basically, uh, deletes the cluster, and basically deletes the cluster we've created with kind. So this is a kind specific command. So kind deletes cluster, and then this is the name of the cluster we're trying to delete. You also have run scaffold. Run scaffold, is also this run scaffold is a scaffold specific command which tries to run a scaffold configuration. I mean, it tries to deploy our application using this profile that we've created, right? So if you check our scaffold.yaml, you can see there's a profile called default. But I'll be coming back to this soon. And also we have dev. Dev is a combination of these two commands, and then we have some funny declaration here just to ensure that we are actually running the commands in the makefile. I think I've ran through this Redis file. Nothing to. I mean, just everything happening here is just basic, right? So we also have a routes, and then we have our scaffold config. First is the name of the scaffold configuration. We have build, which specifies how we want to be, or where our Docker file is, and how we want to build it. Also, we have a manifest, which specifies where Kubernetes manifest files are, right? And so basically, we have it in the K8, and we're asking it to build or deploy all I mean, use the manifest file in this directory K8 to I mean, run those files, and and deploy whichever services to Kubernetes. We also have a port forward, which we are using to port forward our services, right? Redis service, and also uh, you know application service. Yeah. So that being said, let's get right into the code. Okay, first before we do anything, let's run our service. Our makefile. In our makefile, we have a couple of um, commands to run. So let's start with make dev. So make dev actually make dev delete. It first runs clean kind. Deletes cluster, right? Kind deletes cluster, and then it creates a new cluster, right? For us using the config cluster config file, which is here. Um, and also we have this make run scaffold, which runs this guy to deploy our application into scaffold. Basically scaffold deploys our application into Kubernetes. Let's wait for the application to run. So we are running scaffold now. Cluster has been created. So when we do the Docker PS, we see all of our nodes, right? So we have the control plane node, we have the first worker node, and then we have the second worker node, right? So basically, you have a Kubernetes cluster, which we can deploy our application into, right? So Scaffold is trying to deploy that application into Kubernetes, and we actually done. So when we add to localhost 888, remember that is the port we exposed here. That is the port we exposed, so that's why we are able to see what's going. We can also check the other endpoint, which is the points endpoint, right? So you can see we have 2 counts, right? But to explain the concept of the leader election. So currently we have let's set an alias. Okay. So currently when we check the pods that are running, we have 2 pods. Right? One is for our deployment. One is for application and one is for Redis. If we check, currently we can see the logs. Yeah, right. But when we check the logs directly from here, you can see this application is processing the data. Let's say we want to make this service. We want to create multiple instances of this service. So we can scale the deployment and add 2 more services, 2 more instances. This pod is actually being managed by a deployment. So let's get to deployment. Yeah, so this is it. So let's scale the deployment. And then create like 2 more replicas. So but we having 3. So we currently have 1 and we are trying to add 2 more, so that's why the replicas are 3. So it says they are scaled, so let's get that port. So we can see we now have 3 ports ready, right? So we have 2 ports and 1 is in its stage 1 but now we have the 3 ports running. So when we check the logs of the first port, we can see it is processing the data. When we check the other one also, this is the older one and it's also processing the data. Let's check the last one. Also processing the data. So basically we have the 3 services processing the data, but we don't want this. We want just one of the pods to process the data, not all of the pods. So to do this, we need to we need to implement or introduce leader election into our application. And to do that, first we need to you know work with a couple of Kubernetes or a couple of packages that has been provided for us with Kubernetes to start working or to introduce leader elections into the application. So the first thing we need to do, to use this set of packages, we need to, grab our configuration, which is uh, we need to grab our configuration basically whenever you want to interact with your Kubernetes cluster, right? You always need to specify a config file. In most cases, the config file is often found here in your home directory. uh, in your home directory. Sorry, um, let me increase the so and then q config. Yeah, so you can see the configuration. I mean the kube config file. So we need to find a way of grabbing this, and there's actually nice package we can use for this called REST. So when we do REST, just in cluster config. Actually, a couple of ways you can do it, but the most easiest way to do this is using this package. Um, and then we grab it returns a so when we check it returns a config and an error, so we can get the config and error, right? And if there is an error, right, let's just log that fatal f error, right? uh and then so now we have you can see when I saved Scaffold is trying to deploy our application, right? So that's the beauty of using Scaffold, right? So immediately start deploying our application. Uh, yeah, so now we have our config. We need to do something with the config because this cannot use. Okay, let's stick with Fata. Mm, yeah, so now that we have config, we need to do something with the config, right? We need to create a client. So a client is allows us to that's the Kubernetes client package, right? We often use the Kubernetes client package to programmatically speak with or do anything with on Kubernetes or speak with the Kubernetes cluster, right? So all of these packages have actually been installed, right? So we can just do Kubernetes. Is yeah, Kubernetes that we need to create a new config, new con for config, yeah, new for, and then it expects the config. Mm, so it returns a client set, and then error, right? So we can also check if there is an error. We do this. Yeah, so now that we have our client set, we can then create a Kubernetes sorry, we create a lock. Yeah, so remember, right? Yeah, during the Kubernetes for the Kubernetes leader election process, we need to always have a lock. Yeah, and the kind of lock or we need to create a kind of lock. So the kind of lock is either the lease or config map or endpoints, depending on the kind of approach you want to uh, to follow, right? So in this case, because we are using lease, we'll be creating a lease lock, right? So which can be found in the resource lock resource, how to spell resource lock. The resource lock is actually um, also from uh, the Go client library. So when you come here, so what we just need to do to import the resource lock is to go to the tools under Kubernetes, under leader election, sorry, and then we have the resource lock. If I got that correct. Yeah, so you can then do resource lock dot new. Yeah, did I get? No, I didn't get the. Yeah. So resource lock expects a lock type, right? So because we are using a config map, we're using a lease lock type. So we can say resource the lease resource lock. Yeah. So when we check these resource lock, you can see the kind of resource locks that are available to us. We have leader election, resource local annotation key. We have endpoints, we have config maps, uh, and then we have the list resource lock itself, right? So, but if you notice, the endpoints and config map are actually kind of private, so they are not actually available in the current version of Kubernetes. But we know we have access to the resource lock and leader. There's also more endpoints, which is also kind of private, and we also have this. But we are focusing on the releases. So yeah, let's focus on that. Um, we have the resource lock. So what does it? What are the things? Namespace. Let's use the default namespace. The name. One name can we keep this? So let's say lease lock, since we're creating a lock. Core v1 client. So this is where we need our client set, right? Core v1. Then it's also expected coordination uh, from client set core coordination again. So here we also expect the resource log config. Yeah, so inside of the resource log config, we have some I think identity. Yeah, so identity is what we want to use to identify which pod is is which pod as the lock, right? Which eventually means which pod is the leader. So for the identity, we use our identifier, right? So that's all for that. So we now have a lock here, and also it returns an error. And then after we've created the lock, we need to make use of the lock, right? We need to make use of the lock, and to make use of that, we need to create a leader election configuration. Yeah, so we have a leader election. Did I spell that correctly? Um, so yeah, so we need a leader election configuration. Election. Uh, so yeah, leader election config. As you can see, it expects a lock. The lease duration, renew timeline, the release duration, uh, how long the current leader is going to hold the lease for, renew deadline, uh, how long it takes for the um what's it called? How long it takes for or it's basically how long it takes for it to update the list, right? If it exceeds that period, right? So it means there's something probably wrong with the pod, and then another another leader election process will be taking place. So we have a lock, and then it takes in the lock which we created here. So let's just remove this error. Uh, so let's pass this into a variable so we can stop getting this error. So we have a lock, so we need to specify a list duration, how long it takes the leader to hold this list. So let's say every, I don't know, let's say 15 no, 10 seconds is fine. Say renew deadline, let's give it like 5 seconds. We also have a retry period, to, let's say 2 seconds. Well, I mean, this time, this time is actually subjective. Depends on what you're trying to, based on your configuration, how you want to configure it. So can always uh, you can always configure it to suit your use case. So that the callbacks, right? So the callbacks are actually the where we have our function or methods that are in charge of I mean, those methods are actually run whenever events happen in the leader election process. So one of them is we have a unstarted uh, callback function, right? So say unstarted leading accepts a function, and then context here. So when it start leading, what is going to happen? On stop leading, yeah. Uh, let's see. Stop leading is just a function. Mm-hmm. Yeah. So what is going to happen when the app stops leading, and then we have a new leader when this runs whenever there is a new. Actually, it runs always every time, but um, it returns it takes in a parameter, right, and which contains the identity, yeah, and then this identity we can compare it with identifier to check which if this pod is still the leader or not, right? So in this case, let's fill up these callbacks with the logic that we want. So when there is a new leader, what do we want to do? First, we want to check if there is if the new leader is actually the new leader, right? So, and to do that, we use this identity parameter. So we say identity. If identity equals our identifier, then it means uh, let's say fmt.print line identity is the leader. And then basically just return. Okay. Else, if it's not, then we can say, yeah, fmt the print line identity uh, is now the new, oh god, new leader. So when it stops leading, what can we say? Let's say, let's just use identifier here. No, identifier, not identity. Identifier is identifier as stopped. So when it start leading, what do we want to do? We actually want to run this processing data method. Yeah, right. So yeah, so that's basically what we. I mean, that's basically how we configure our leader election. I mean, our leader election. Configurations. Uh, yeah, so now that we have our configuration, we need to do something with this configuration, right? So we need to create an elector, which we then run, right? So to create the elector, we say leader election dot new leader elector, right? And then we pass in the leader elector configuration, right? And then it returns an elector, as you can see, and an error. So we have L elector and error. Yeah, so if there is an error, we basically do this. We uh, log a fatal error, or basically just crash the application or something. So leader elector dot run expects a context, right? Yeah. So we've actually set up our application. So once we save, scaffold would try to uh, scaffold will try to deploy our application into Kubernetes. But the problem here is that because we are trying to communicate directly with Kubernetes, right? We would actually have some authorization problem, right? Because we didn't specify our pods are not given the permission by default to be able to interact with Kubernetes. So we need to set up some role-based access control configuration to enable that, right? So, by just simply running this, would have some failures. Uh, but let's wait, see, and see what's going to happen. This could actually take time because now uh, we have more files or more packages. Uh, application needs to download during the build phase. So that's why it's taking a little time. Uh, but then uh, I think we can let's just wait for that to complete. Yeah, so that took a while. Yeah, so our application has been deployed, and as you can see, we are getting some authorization error, right? It says user system service account cannot get resource leases in API group. So what this means is basically we need to set up or create a service account, right? So in our KIT directory, let's create a service account. What is it? First we need to create a service account, and to do that, let's head over to the Kubernetes documentation and grab a service account. Service account. Let's keep configure a service account. So let's grab this, and then what's going to be the name? Let's say these SA, right? And then this is actually not to. Well, let's just add it default. Uh, uh, we also need to create a row. Yeah, so row. Let's check if we're going to see what this is. Nope. But let's grab that. And we're creating a row. The name of the role is going to be, let's say, lease row, and it's going to be actually for leases. We want our application to be able to get watch list, create the list, create the list, update the list, and let's add patch also. Patch. And then we finally need to create an a row binding, right? So let's grab something. Row binding. I think a row binding should also be here. Yeah. So we have a couple of row bindings. Let's check if you're going to see one for service account. Okay. Let's just grab a row binding, and where is it? Let's just grab any one of these and then we can change. But first, let's clean up all of these. Uh, so we have a row binding. What's going to be the name? The name is going to be row bind. Let's say lease row binding, just to follow the convention we've been. Lease row binding. Namespace is default. Kind is going to be a service account. Service account. Name is lease SA. I don't think we need an API group, and let's say namespace is also going to be the default namespace. Yeah. So we have a row binding. No, so this is supposed to be row, not cluster row, and it's going to be lease row. And then the API group is authorization. So let's cross check and see if hopefully we didn't make any mistake. So we have our service account in the default namespace. We have a row binding with with the following verbs: get, watch, list, create, update, patch, and the resources for the leases. And then we have a row binding. Okay, there's an error in the name. So lease row binding. We have a service account, we have a lease, I say, and mm, let's queue this. And also, I do not want I do not want scaffold to run when I save, so I'll just queue it. So let's save that. But mind you, after creating all of this, we still need to ask our I mean, our application needs to use this, so we have to come to the template spec of our I mean the template spec of our application, and add a service account or service account name. What is going to be, please say. Yeah, so uh, let's just say service account name, right? I think that's all. So just trying to cross check if there is no mistake, any spellings error. Yeah, so we can then make run scaffold. So that should deploy our application, right? So application is being deployed. So we are still getting an error. Are we getting an error? Or this is an older? Cannot get resource leases namespace default. Let's check. So let's see what's going on. So we have lease SA. We also have a row binding clause. We have a row binding and we also have a row. Lease row. Let's check. Get what list create and update. Row binding. Describe. Describe row binding. Oops. So from we have our row binding this row. Okay, so let's get ports. So I'm not too sure why we're getting that error, but then did we spell something wrong? Let's also check if actually our port is using the service account. So if you get port, or let's go through the deployment route. Spec template. Okay. Let's check if you see any service account. So we have a service account here. So what could be wrong? Mm-mm-mm. Okay, so what we do is let's recreate the cluster, right? Using make that. Hopefully that doesn't take too much time. So after recreating, try to recreate the still having the same error. Okay, this is let's see if we include this to API groups. Oh, we actually got the error because we didn't specify the API groups. Uh, yeah, so as you can see, our pod is running. Current pod is the new leader, and it's processing data. So when we go to the browser and try to run, so we see one, it's now two. Let's refresh for a while. But this you can see the requests that are coming in. But to yeah. So uh, let's get pods. Yeah. So but let's you know add few more pods so we can see what exactly is going on. Okay, scale deployment. Replicas 3 deploy. Sorry about my typos. So let's get pods. So we have 3. So the 3 are now running, right? But let's check the list, right? Let's check which pod is holding the list. So we see this is the order of the list. Let's uh let's check a few more information about the list. Describe list. Oh, describe list log. So we can see information about the lease, right? So acquired time, this was when the lease was acquired. The order of the pod, this is the order of the pod. The lease duration, order of the pod would hold the lease for this long, for 10 seconds before then there's a renewal process uh, happens. Uh, and then we have some other configuration. But that's all about the lease. But let's see. Let's get the pod and try to. This is the port that is actually holding the lease, which is L9JPD, right? So let's see if anything is going on in this port. We can see that it just says one leader. I mean, in leader that's attempted to acquire lease. If it attempted and then it failed, and we got the LP9, which is this L9 JPD is now the leader, right? So it was unable to acquire the lease. This is the LP9. Let's see what's going on inside of it. You can see it is no, it's still the one processing the data, right? So let's check the last pod, which is this guy. We can also see that this is now also processing. Let's see what happens when we delete the pod. Uh, Here, so delete the pod and let's try to get this and see who the order is. So the order is still L9, but when we try to run it again, it should have changed. Yeah, so a new leader has been elected, so which is 5x. This guy is now the new leader. Let's check what's going on inside of it. You can see it has also started processing the pod while uh, I mean, processing the workload. But 5x, right? Yeah, it's processing this. Is it processing this? No, it's not. It's not processing. This is also not processing. Yeah. So basically that's how when we check the yeah. So we also have so basically that's how you implement leader election in Kubernetes. I'll be providing the link to the repo. In the uh, I'll be providing the link to this repository somewhere in the description, so you can get you can have access to this code basically. So that's how to implement leader election in Kubernetes. Hopefully you find this video interesting or educative. Also try share with friends and anyone you feel might benefit from this. So thanks and take care.